Hi again. I wanted to take a look at one of the problems on Unit 2 Worksheet 1AP. Specifically, I'd like to look at number 3, which is the one where the pilot is flying along the ground about 35 meters above the ground when the ground starts to slope up, and she has to pull up on the stick in order to not hit the ground. So let me see if I can draw this situation. Here's the ground. So here's the ground. And then the ground starts to slope up. Now this is a much exaggerated angle because 4.3 degrees is a very small angle and you wouldn't even notice it so much. So that's 4.3 degrees right there. The pilot is flying right here. It's my best shot at an airplane and is flying this way. So we know that this height, this distance right here, is 35 meters, right? And what we need to do is realize that the pilot's going to strike right about there. And so we need to find this distance, I'll call delta x, that is how far the pilot will go before she hits the ground. From the moment, that's a horizontal distance, from the moment that the ground starts to slope up. So we know that the velocity of this aircraft is 1,300 kilometers per hour. Yes? So in order to find the time she has to react, we're going to go back and use our basic equation that we use for constant velocity motion. The plane is flying at a constant velocity, and so that is this equation right there. And so to find the time, I just solved this equation for t. Time is equal to delta x over average velocity. And so now you can see why we need to find this delta x. So, but we also need to find the velocity. Now you might say, wait a minute, we've got the velocity. And that's true, we do. But it is in kilometers per hour. And since we're dealing with meters here, we need to deal with meters everywhere. Or we convert that to kilometers, but that would be a very small number. And also, we don't want hours. Presumably, we want to know how many seconds she has to do this, not how many hours. So let's convert this first. Doesn't really matter which I do first. So it's 1,300 kilometers per hour. Now, what I want to do is I want to multiply this by some factor. Let's say I'm going to convert it to meters first. Some factor that equates kilometers to meters. So we know that there's 1,000 meters in a kilometer. And I want to set it up as a fraction where the kilometers are going to divide out. So I know that there's 1,000 meters for 1 kilometer. And so now I can see that if I multiply these two numbers together, kilometers are going to divide out. So right now my answer would be in meters per hour. It's not quite what I want. So I need to get rid of the hours. So 1 hour is 3,600 seconds. So there's 60 minutes in an hour and 60 seconds in a minute, so 3,600 seconds. And when I do that, I get a velocity that's about 361.1 meters per second. So it's moving right along, right? Okay, let's turn our attention over here now to finding delta x. So down here, I'm going to just take this part of the drawing and I'm going to reproduce it as a triangle. So we know that that's 4.3 degrees. This side is delta x. Now the side here we know is the same 35 meters, right? If I brought this over here and dropped it down, the pilot is 35 meters above the flat ground level. So I know that that's 35 meters. And if I'm looking to solve this for delta x, I'm probably going to have to do some triangle geometry or use a trig function. So you might recall from your math class, and if you don't, now's the time to recall that the tangent of some angle is equal to the opposite side, which would be this side, there's the angle, divided by the adjacent side, which in this case, the opposite side is 35 meters, and the adjacent side is delta x. So if I solve this equation for delta x, I get 35 meters divided by the tangent of 4.3 degrees. Now, by the way, you want to be a little careful with your calculators because in math classes, a lot of times they're in radians. And in physics, we're going to be using degrees. And so you want to make sure you get them the right way. So when I do that math, I end up with 465, about 465.5 meters. So now I've got this number, and I've got this number, which I'm going to use in my calculation of time. So the time is approximately equal to 465.5 meters divided by 361.1 meters per second. So let's take a quick pause and look at the units. So in this particular case, I've got meters over meters per second. So if I multiply the top and the bottom of this by seconds over by seconds, you can see that these will divide out. These also divide out, and what I'm left with here is seconds, which is what we want. It's a time. And so the time becomes approximately 1.29 seconds. And so she has about 1 1/3 seconds to pull up on the stick to avoid hitting the ground.